With this last try it exercise of the section, just a simple reminder that just because it looks like we may not be using a specific property or process, doesn't mean that that's not the easiest route. So it's important to remember different forms, our methods of factoring, so on and so forth, in solving quadratics, because there might be a much simpler route than what we're trying to take. For instance, if we look at this problem, 9m squared minus 12m plus 4 equals 25, we might be tempted to just divide everything through by 9 and then complete the square. That will work, but it's much simpler to recognize that this is a perfect square trinomial. It's a lot easier to factor than completing the square. If we look at a perfect square trinomial, it factors into something that's being squared. So if we look at 9 and 4, and we look at that middle term of negative 12, we should recognize that 9m squared minus 12m plus 4 is a perfect square trinomial in which this factors to 3m minus 2 squared. 3m squared is 9m squared, minus 2 times 6, or 2 times 3m is minus 6m, then another minus 6m from the 3m times negative 2 on the outside, and then the last terms, negative 2 times negative 2 would be 4. So this does multiply through to equal our original. The key is we need to recognize it as a perfect square trinomial. And remember, that's when a squared minus 2ab plus b squared equals a minus b squared. And in this case, the a is going to be 3m, and the b is going to be 2, where we get the 3m minus 2 squared equals 25. Now we're back to the same type of problem we've been looking at this entire section. We invoke the square root property. We take the plus or minus square root of the right-hand side, square root of the left-hand side. Square root of 3m minus 2 squared is just 3m minus 2 equals plus or minus square root of 25 is just 5. So we'll add 2 to both sides, giving us 3m equals 2 plus or minus 5. And last but not least, we'll divide both sides by 3, giving us m equals 2/3 plus or minus 5/3. That will simplify fairly nicely. M equals 2/3 minus 5/3. That's negative 3/3, which is negative 1. Or m equals 2/3 plus 5/3. That's 5 plus 2 is 7/3. As always, we check our solutions by substituting into the original equation. So we want to know, does 9, let's go with negative 1 first. So 9 times negative 1 squared minus 12 times negative 1 plus 4, does that equal 25? So negative 1 squared is just 1, so this is 9. Minus 12 times negative 1 is plus 12. 12 times negative 1 is negative 12. Minus a negative becomes a positive. Plus 4, does that equal 25? 9 plus 4 is 13, plus 12 is 25, or 9 plus 12 is 21, plus 4 is 25. Either way, 25 equals 25, so that solution checks. Now, what if it equals 7/3? What if m equals 7/3? So 9 times 7/3 squared minus 12 times 7/3 plus 4, does that equal 25? Well, 7/3 squared is 49 ninths. 9 times 49 ninths is 49. Minus 12 times 7/3, that's 12 divided by 3 is 4, times 7 is 28. Plus 4, does that equal 25? So let's do the addition first. 49 plus, or 49 plus 4 is 53 minus 28 does indeed equal 25. So our second solution checks, telling us that if 9m squared minus 12m plus 4 equals 25, then m equals -1, or m equals 7/3.